Section 2.2 has to deal with proportional reasoning, and I want you to be able to apply proportional relationships to rates, similarity, and scale. And you did a lot of this last year in geometry with similar triangles. So just want to quickly go over some vocabulary words. Ratio is a comparison of two numbers by division. And one example is 3 over 4. Now last year you probably did ratios as 3 with a colon, 4. And you can also write out 3 with the word TO, 4. A proportion is an equation stating that two ratios are equal. So ratio is just this, proportion is an equation. In a proportion, the cross products are equal. Okay, when we go to solve a proportion, you just take the cross products. So here, we're going to multiply n times 5 and 3 times 14. So we'll end up with an equation then when we do the cross products, and it's 5n equals 42, and divide both sides by 5. Now, if your answer is irrational, do not round your decimal. And the reason why I'm saying that is when you round your decimal, it's not an accurate answer. If you round the answer and you substitute n back in here, you're not going to get the same answer, because with a proportion, the two ratios, the ratio on either side of the equation, they have to be equal. So again, if you're rounding your answer and you substitute it back in, they're not going to be equal. So here, it's a rational number. It terminates after 4.4. And so it's okay to leave it like that. Now, when we go to the other side, you want to be real careful, because one of the biggest mistakes I see students make is to tell me that when I multiply this together, I get 34n plus 1. So be real careful to distribute that 17 to both terms. So when we do the cross product here, not a bad idea to put this in parentheses, and then you can see that you have to distribute the 17 through. So we have 34n plus 17 equals 190, and then we can subtract 17 from both sides to get 34n equals 173. Now this time when I divide by 34, I'm going to get an irrational number. If you notice you put that in your calculator, it's going to go all the way off your screen, and there is no repeating pattern. So that's an irrational number. So we're just going to leave it as n equals 173 over 34. Okay, those are straight proportions. Now, you can always check your answers. Here I just took 8.4, put it over 14, and then if it is a true proportion, your cross product should be equal. So, or when you reduce on this side and reduce on this side, you'll get the same answer. All right, here's a couple of different ways that you can set up a problem that's involving percentage. You can use method 1 here is use a proportion, and you've probably heard different times. Is over of equals percent over 100, or percent over 100 equals part over whole. Either one of those will work. So here we know that we have 11.5%. So that tells you right away that that's the percent part. So here they have it, I have is over of equals percent over 100. They have percent over 100 equals part over whole. Same thing. So we know that the percent always goes over 100. So we have the percent over 100, and then we have to decide if this 2,400 represents part of the students or the entire student body. Well, because it says 2,400 students are attending the college, we know that's the entire student body. So that's the whole. And we want to know what part are of the student body, how many are majoring in engineering. So the X would go over the 2,400. So the percents on one side and the numbers of the student body on the other side. Okay, then you can just use the cross product. And when you solve, you have 276 students. The other method that you could do, since we know that we're taking 11.5% of this, you can just change 11.5 to a decimal. So that would be moving the decimal, like dividing by 100, so you're moving the decimal 2 places. And then we can just multiply that by 2,400, and you'll end up with the same answer. Okay, so let's do a couple of examples of setting up a proportion and solving it. All right, we have that 1,300 students at Swartz Creek, 278 play a sport. What is the percentage of the students who play a sport? So on one side I'm going to put the students, on the other side of the equal sign I'm going to put the percent. Okay, so what are we looking for? We're looking for the percent of the students. So we have the students on this side. I'm going to put the part over the whole. So the 278 is going to be part of the student body, and this is going to be the whole student body. Okay, so that means when I write this out, I'm going to do 278 over 1,300, and we want to know the percentage. We want to know the part over 100%. So then you can just do the cross product. And we have 1,300x equals 2,000. Actually, that would be 20. If we put 2 zeros here, it would be 27,800. So that's going to give us x equals 21.384. Now, before I said do not round, but here, if I'm added the instructions here, round to the nearest tenth, because we're trying to find the percentage. So we're just going to say that that's going to be, here's the 10th place right here, so we need to look over here, and that's going to make that it's going to be 21.4%. All right, the next question has to do with similar triangles, and you did a lot of this last year in geometry, and looks like I need to change the foot to feet because it's 6 feet, not 6 foot. So we have, here's our problem. We have a 6 feet tall climber cast a 20 feet long shadow at the same time that a tree casts a 90 feet long shadow. And we want to know how tall is the tree. Well, one way, if you're not sure how to set this up, just sketch a couple quick triangles, and they don't have to be to scale. As you notice, mine off to the side here are not to scale, but this is the climber, and this is his shadow. So, since I put the climber here and the shadow here, when I set up the second triangle, I have to put the climber here and the shadow here. I know that the shadow of the second one is 90 feet, so I put that here. We want to find out how tall the tree is. Now, I could set up this proportion several different ways. I just need to pay attention. However I set up the left-hand side, that's how the right-hand side has to be set up. So, the first thing I did is I did 6 over 20 on this side. So I took the climber over the shadow, and I have to do that on the second side. The climber over the shadow. Now, if I did the shorter climber over the second one, so 6 over x, I would have to do 20 over 90. So I can set the proportions up more than one way, and I could actually, there's more than 2 ways to do it as well, but I'm just showing you, as long as you set this side up, then this side has to follow it. However you set this side up, this side has to follow. So now when I do the cross products, you're going to see 60 times 90 here, 60 times 90 here. So it's going to be 20x equals 540. And then when I divide by 20, I end up with 27 feet. So that's how tall the tree is. Okay, you have 4 questions on the back for tomorrow.